Welcome back. Let's talk about how we're going to match up these pink cards with what we've already done with the yellow and the blue cards. If you remember from the previous video, we were looking for patterns with even and odd exponents. So something with an even exponent, like x to the 8th, you could factor that into x to the 4th times x to the 4th, because when you multiply these two expressions together, you do get x to the 8th. If I were to factor it even further and break it down into perfect squares, then I would have 4 of these x to the seconds. Each one of these is a perfect square, and I could square root every single one of these. I could square root x to the 4th, and I would get x squared, and I could square root this x to the 4th, and I would also get x squared. And x squared times x squared is x to the 4th. Remember, a square root is a number times itself that multiplies to make that. This expression times itself makes x to the 8th. So x to the 4th is its square root. However, for something like x to the 9th, you have x squared times x squared times x squared times x squared times x. Because this is an odd exponent, there's an extra little x there also underneath the radical sign. And here we have x to the 8th times x. It's just this expression, x to the 8th, written as one variable with one exponent rather than separately with an extra x after it to get up to that 9th power. Well, we've already discovered that the square root of x to the 8th from here is x to the 4th, but then we still have one x left under the radical. Let's go back up to the top. When we try to factor the square root of x squared, there's really nothing that we can do with that. It's a small expression, I guess you could say, but when we go to simplify it, we could think of it as just x. And part of the reason why we do that is because we know that squared and square root are inverses, so we could be left with that. But also, if you remember, that x to the 2nd power and then the square root is the same thing as the 1/2 power. And the power to power rule says that you're able to multiply these. And 2 times 1/2 is x to the 1st, which is the same thing as what you have here. Just two different ways to think about it. Again, with x to the 3rd, we've got x squared times another x to get up to that exponent of 3. There's really no other way to break that down further for factoring. And so this is the way to simplify that. The square root of x squared, right here, that is this x. That was able to be simplified because x squared is a perfect square. However, there's a remaining x underneath the radical sign that doesn't get simplified. Here, when we simplify x to the 4th, well, you can see that there were 2 of these in there. So each one of those gets square rooted. This one and this one, they both get square rooted, that's why it's x squared, and then the root x is left underneath the radical. A number times itself that makes something is its square root, and then this one goes right there. The square root of x to the 6th is x to the 3rd, and then the root x is left underneath. Again, take a moment to look for patterns, and then write yourself some explanations in this column so that you can remember how this original and then these other cards are all related to each other, and then go on to the next video.